Good morning all. It's kind of postbag, but it's not really postbag. But I do have to open this one because it's potentiometers for my vocoder project. Here they are. Cermet, I think they're sometimes called trim pots. So these are all the values that I couldn't find in my trim pot box. I think this box is going to need to be a bit bigger to handle all the different values because I've already mixed some of the values up. But yeah, I should have the full set now. And these pots are for this Project Vocoder. I'm rebuilding a 1980s vocoder. And I'm building this section here with the transconductance op amp and the filters, but they're going to come slightly later. I'm really concentrating on this area here at the moment. And there is a potentiometer, a full-size potentiometer, but 3 trimmers, one there, and one here. And this one, 22K, I think that's the one I got stuck on, so I had to order these. And, of course, wait the 3 weeks for them to arrive. So this is where I'm at with the vocoder. It's made up of these green prototyping PCBs, which hang off the front panel courtesy of the pots. It's really only the pots that are holding these boards onto the front panel. And I've been working on this one. So let me take that off the front panel and we'll have a closer look at that. Use my favourite spanner, 10mm and 13mm. Probably the two most useful sizes there are. So this is the board. We've got the pot and the 3 trimmers. Now you notice this one's loose, and that's because I think that's the 22K and I didn't have the right value, but I just put that there to sort of get clear in my mind where things were going to go. Now the problem with this is that I need 2 of these circuits. This transconductance op amp actually is in 2 halves, so that's why it's sitting in the middle of the board. It's that 16 pin, is it, device. So each half is taken by each channel. And these channels are, well, they're identical circuits, but they'll have different component values in the filters so that they operate at different frequencies. Now I'm fairly certain that I'm not going to be able to fit everything on this board, even though I've gone for the highest possible density layout style that I could come up with. I sat and stared at this board for about 3 hours, I think it was, before I actually even put the first component on, which was this chip, this IC, because I just wanted to get this density of layout. I didn't want these great long wire runs, which I had on some of the other boards. So you can see on this one, for example, I mean, there's only one chip on here, because really this is all about the density of potentiometers. How many potentiometers are there per everything else? Well, here there isn't much other circuitry relative to the number of potentiometers, so you end up with a fairly sparse board. And as I say, it's just one dual op amp here. It's 2 sections, I seem to remember. I think this is the oh, this is just a comparator, that's right. So a lot of the space on this board is wasted with these long links and these long wire runs. Now, all the circuitry isn't going to fit on this board, so I can see there being a second board sort of double-decked on top. And for that reason, and I'm kind of thinking I might just chop one of these boards down the middle, and that will become my second layer. So I needed to get all these trim pots right up at this end, near this potentiometer, so that you can actually get a screwdriver in to adjust them, because there's no point putting pots on the board and then putting a second layer on. You can't get to the pots. You've got to think about these things. Now, I'm fortunate, of course, that all these presets, PR3, PR2, and PR4, are all in this area of the circuit and near the potentiometer, the full-size potentiometer, this thing. So, yes, I could fit it all into this small space. But I've done some quite cute little tricks to pack more components in. So for example, we've got this resistor here, which I think is 1 meg, sitting underneath these 2 trimmer potentiometers. If I take this one out because it's not fixed in, you can see how the leg sort of sits underneath, well, and part of the body sits underneath the trimmer capacity, and this is just really to try and get that density of components so that everything will fit on this board. Right, that's a 204. I don't want a 204. What's 204? That's 200k. I want a 203 or a 223. Let's see if I've got that. Right, so there they are, 203. So it's going to be 20k, not 22k, but it's a trimmer pot, so it doesn't really matter. I've got some 104s, 202s, 102s, and 101s. I've got 101s in there. I think what it is there are so many. There's one per channel, and there are 14 channels. I just thought I probably don't have enough to make 14 channels, so I just bought some more. So let's put all these in this box. Yes, now of course they don't fit in here, so I bought some more of these actually. I bought lots of different styles of these little plastic cases, so they'll be appearing in a post bag soon. Right, so this 22k or 20k as I've got, only 2 connections are being used, so I'm only using 2 legs of this. One goes to the junction of this 1 meg and the transistor. The transistor is going to sit in this little 3-pin socket. So one of the connections goes to that link, which is that junction there. The other connection goes off to this op amp. And I think this op amp is split IC5. Yes, it's half of a 1458. So that'll be another op amp that sits in the middle of the board, with each half being used by the 2 separate circuits. Now, because of the symmetry of these 2 circuits, I've already taken the decision that on one channel the trim pots will work one way round, and on the other channel they'll actually work in reverse. I don't think that's a major issue for trim pots because you're only going to adjust them once, so you can sort of cope with that once. What I couldn't do is I couldn't do that with the main pots, because they really do have to be clockwise for an increase in level. The main pots there, it's just increasing the level of signal fed from the output, which I think is this pin 5, to a transistor buffer stage, which just sits at the back of this chip. So they've implemented the volume level control here. So yes, these had to be asymmetric. All the wiring for those is sat under the pots. It's quite difficult to see, but you can see that there's an asymmetry in the way I've linked from the chip to the pot. On one side is different to the other, because of course these had to be, well, I couldn't put them opposite ways round for level. So my next decision is how close do I put this device, IC5, which is a dual op amp, so it's an 8-pin device. How close do I put it to this IC? Do I put it right up against it, or do I leave one hole as a gap? It'd be nice to leave a gap, but I'm not sure that I actually need to leave a gap. Now, if you think I'm deliberating far too much over this, it is worth it, because there are actually 7 of these boards, because there are 14 of these filter circuits. So this one is the middle one, notionally, it doesn't really matter, but then there's another one there, another one there, and another one up at the end. So there are 7 of these boards. So it's worth getting this as close to what I want as possible. I mean, I don't mind making small tweaks for the ones either side and carrying on making changes as I go along, as I make mistakes on this one. But I quite like to get these as dense as I can. So I've just written the numbers on here because a lot of the numbering is missed off on these schematics. So the diode's nice and easy because that goes either between pins 1 and 2, so they're right next to each other. So that would be tipped up on end like these resistors are. That'll be easy enough. It also goes 6 to 7, so there'll be one on one side of the chip, one on the other. This resistor goes from either pin 2 or pin 6 to ground. Well, my nearest ground point is the base of this transistor, in other words this point here. So that'll be easy enough, going a resistor from pin 2 on one side and pin 6 on the other to the midpoint of that transistor. Yeah, I think I'm just going to shove that socket in now. So I'm going to make this IC socket using these turned pin strips. So I need 2 4-pin strips, tip it one way and then back the other to get that to break nicely. So tip it one way and then the other. So those are the 2 strips for my socket. So let's just fit any old chip that I've found into these 2 sockets, and then I can place this in the board and get it all lined up. This chip will just hold these socket pieces in alignment while I solder it in. So that's going to go there. I think I will leave that 1 position gap. It just doesn't feel right to wedge that right in there. It all looks a bit too tight. So I'll leave that gap. If it turns out subsequently that I could have used that space, maybe I'll do that on the next one. But yeah, that's fine. So I'll just hold that in and tack these on. Now the question is, do I use the USB soldering iron? Because I do have some concerns about that. So yeah, my major concern with this is thermal mass of this tip. It is very, very thin, and so it hasn't got much thermal mass. Now that's good from the point of view of it heating up quickly, but of course with that constant current, and when I measured it, it uses the same current to heat this up as the quiescent current to keep it warm. That current's really way too high, and this thing, a couple of people said in the comments that this gets extremely hot, 600 or 700 degrees, which really is too hot for sensitive components. So I did have in the back of my mind the thought that the 555 in there could be taken out and a PIC could be put in there to initially provide full current via that MOSFET to the tip for say 10 seconds to get it warm, and then back it off using pulse width modulation to keep this at a nice constant temperature. But yeah, that's a project for another day. So I am going to give this a go with this USB soldering iron. I've blue tacked in the component and the socket effectively. So let's give that a try. Let's warm that up. Why isn't it warming up? Is the power bank switched off? Probably, yes. So it's a bit of a dual thing really. You've got to switch the power bank on and then switch this on. And then you really have to hold that tip, that button, to keep this on. Now, is this going to take solder? No, you see the tip's not taking solder again. So it's coated itself in something nasty. I have to liberally apply solder and roll it round to coat the tip with my solder. I did coat it with lead-free solder. I need the sponge. Right, let's have another go with the sponge. Take solder. Yeah, that seems very hot because the smoke coming off it is very vigorous. I mean, it's soldering fine, but it just feels very hot. It's okay. And I mean, it doesn't really matter if I kill the chip that's in this socket, but that's no good if you're using... Ah, that seems to have... Ah, holding that doesn't work. Holding your finger on there doesn't keep it on. Let's check that. Because that went cold and it wouldn't solder. So I'm going to hold my finger on there. I think the little springy contact thing, the vibration sensor, keeps this thing on if you're moving it around. Oh, that did re-trigger then. That's interesting. But it cooled down and I couldn't use it just now. Well, that's it soldered, and the joints look pretty good to me. I'm quite happy with that. So yeah, that soldering iron is usable. Right, I better take this chip out because for one thing it's the wrong chip, and the other thing is it's the wrong way around, and it's just going to confuse me in terms of the pin numbering. I mean, I only put it in there to line up the 2 rows of sockets so that they'd end up nice and neat. Oh, these things are always a pain to get out, aren't they? Right, okay, so now I can start thinking about components. Right, so this diode is, what is it? It's got to be a 1N4148. Yeah, 1N4148, so I've got some of those. And this resistor is a 3K9. And I was watching Taboo the other evening, which is rather excellent, and marking these up as I went, but I started at 10K and I went upwards, so I haven't got a 3K9. These are sitting in this cabinet drawer, which they fit in rather well. Certainly height-wise, they fit brilliantly well. It actually even tucks under that front. So I just need one more row, so I've ordered a few more of these. But no, that's not going to be many, is it? That's only going to be 33. So it's only going to, it's not going to take many resistors. I'll probably need several drawers of these if I'm going to carry on this storage idea. So it's back to my rather more basic storage idea. Oh look, there it is, 3K9. I can see it in there. So let's get a 3K9 or a couple of those. Yeah, 3K9, they're in here, so I need 2 of those for the moment. So 3K9, orange, white, and that would have been red in the good old days, but now it's black, brown. Now, here's something to agonise over. It would make sense in terms of inputs and outputs to put pin 1 over there, because pins 1 and 7 are the outputs, and they sort of flow into this 16-pin chip. The inputs are more this side, and that's coming from whatever circuitry is here. So it makes sense to put it that way around from a sort of flow point of view. But then pin 1 would be in that corner, and pin 1 on this chip, this one. So the 2 chips would be facing each other, which is just not done. So yeah, I'm just sitting here sort of agonizing over this. Do I have a non-standard layout where the chips face in opposite directions and have my connections a bit easier and neater? Or the other way around? Oh, I could sit here for hours trying to work this one out. And also the very high heat of that soldering iron bothers me a bit with things like this diode, which is sat right down on the board. That very high temperature, I mean, it could affect that diode possibly. And once you solder things into these through-plated holes, they're very difficult to get out again. So yeah, decisions. Yeah, I'm not sure I can go with this thing about having chips pointing in opposite directions. It just looks wrong. These are just dummy chips I've put in the sockets. They're not the actual chips. But it's going to lead to so much confusion, particularly if I do it on this board and then I don't do it on the other boards. I think the chips have to be pointing in the same direction. It's just not going to look right like that. Right, so let's get these diodes in, despite the 700 or so degrees on this soldering iron. I hope the thermal mass of the via, or the through-plated hole, will protect the component. Let's spin that round. Do the one on the other side. And if it doesn't work, then obviously I'll suspect these diodes. Has that gone off? That's gone off. Why's that gone off? This thing is a bit flaky with regard to switching on and off. Yeah, really the biggest problem with this soldering iron is pressing that and holding it doesn't always seem to keep this on. So 3K9 goes from cathode of diode to ground. Ground is this point here, which is base of the transistor. So cathode of diode is that hole there, or adjacent to it. Base of transistor is the middle pin of these 3, so it really just spans that gap at a diagonal angle. Is that going to look okay? It'll be fine. This one's slightly different because the diode's moved out a bit, so it actually spans. Well, I suppose I could connect it there, unless of course I need that pin. So that's 1, 2, 3, pin 3. Yeah, I probably do need that pin. But then I might be able to tap that pin off inside the chip. Oh no, I can't do that because there's a couple of 12K resistors going to be sitting inside here, which is this component, which goes from pins 2 and 15 of this big chip, which are there, 2 and 15, across to plus 12 volts. Well, that's pin 8 of this chip, which is now there, I think. So yeah, there's going to be 2 resistors sitting in there. Oh, it's just complicated stuff. Right, now the interconnect. So what I've done is I've cropped the leads on this resistor, this one very close, but enough to bend it over and join it on to this line here, which is ground. So let's place that in place, and then I just need to blob solder onto that joint to connect this point, which is the resistor, onto this ground point here. So let's do that. Oh, I made a bit of an error here. The diode, which is sitting across there next to the chip, I was supposed to leave the legs on to bend them over and link them onto the chip. So I'm going to have a problem now, because it's actually quite difficult to bridge this gap with solder. They're just sufficiently far apart. If they were only just a tiny bit wider, then bridging the gaps would be easy. But yeah, that was a total disaster really, because that's the whole point of leaving the legs on, is to bend them over and link them onto the two chip pins which they're supposed to connect to. So I'm going to struggle with this. On this one I might use this long wire, bend it, put it onto the diode and then bend it round and take it onto the chip. Same with this resistor leg here, but yeah, that was a bit stupid really. Yeah, this soldering iron I'm afraid is a pain, because it's never on when you want it. It keeps switching off. I'd rather have, quite frankly, a main soldering iron that's on all the time and sort of holding a nice steady temperature. Right, yes, I think that's worked. Yeah, I'm sort of virtually really at the point of giving up on this USB soldering iron. Right, now I'm going to attempt to bridge this gap with just solder alone, but it's going to take a lot of solder. I've got to make sure this is on. I've taken to keep... Come on, switch on. I'm taken to keeping this red light in the corner of my eye so that I can see whether the iron's on or not. But right, lots of solder. Let's bridge this gap. Okay, masses of solder, yeah, so I've managed to bridge that one. Let's bridge this one over here. Again, feed lots of solder in. Oh no, that came back. Yeah, I've bridged the gap, but it's not ideal to bridge the gap without a piece of wire in there. So you want to be careful not to crop the leads before you've thought about where they're going next. Right, well now I've just had a bit of a disaster really, because I noticed that this 12k resistor that goes to pins 2 and 15 was already in the board, but unfortunately I'd put 22k in by mistake. It reads 12k if you read it from one end, the wrong end. So I've had to take these two 22k resistors out, and trying to get resistors out of this kind of board with plated through holes and legs that you've bent over on the bottom with a soldering iron that's really far too hot is a recipe for disaster. And I've got tracks that have lifted off and it's all turned into a bit of a mess, quite frankly. Right, the proper 12k resistors are in now. Brown, red, black, red, brown. The last brown, of course, being 1%. They're in, but the board's a bit of a mess. You can see here next to the chip and here the pads are missing and the resistor leg is poking through, connected to the right place, but there's no pad there and there's no pad there. Everything got a bit hot and got a bit burnt. And these two 22k resistors, which are supposed to be 12k, that band does look a bit brown. They're supposed to be 12k. Let me just light that up with a torch. I think you can see that that is a red band at the end and a brown band at the other end. Well, anyway, they were wrong. I measured them with a DVM. They've come out, they're destroyed, they're going in the bin. So I've soldered in these 20k pots, which are the new edition that came in that yellow envelope. This socket is there for the op amp. So yes, this board's moved on a bit, not really a lot, and these 12k resistors that I found out were 22k has set me back a little bit, but yeah, a little bit of progress. And the verdict on this soldering iron, yes, I think it would be absolutely brilliant for doing a very quick one-off solder joint where the 10-second warm-up would be extremely convenient, and just plug it into a power bank if you keep one on your desk, which I do. But for a sustained soldering session like today, the fact that it's always off when you come to use it, it starts to become a real pain, and I don't think I'd use it for anything other than just a quickie joint now and again. And I don't think that the extreme high temperature that this tip gets up to when you're using it is doing that tip any good at all. I mean, it already looks like there's possibly a bit of the coating has just been eaten away by the high temperature. I'll just give that a scrape with a knife. So yeah, the iron seems to have bits of coating missing there, and it's probably still usable, but this tip is suffering, I think, more because of the high temperature than anything else. And actually, if you look at the sponge, you can see that it's all burnt here. So this iron's really too hot. Yeah, my verdict is use it very occasionally for a quickie joint, but it's not going to last long. If the tip's being destroyed at this rate, it's not for a long soldering session at all. So there we are, board updated, a few components added, not really a huge amount of progress. USB soldering iron used in anger and don't particularly like it. I think this video has probably got long enough, hasn't it? So I'm going to say cheerio.